Hello, and thank you for taking the time to view our presentation of the IT Oxygen Vulnerabilities Management solution. IT Oxygen is a cybersecurity, software engineering, and information technology-focused enterprise here at Michigan Tech, and the project has been developed by Stephen Garrett, Trent Verbodenkoer, Charlie Petrick, Lucas Jones, Joseph Wazalewski, Joseph Van Lian Thung, and Cedric Ector. The purpose of this project is to develop a cyber health reporting tool focused on STIG compliance. The exact meaning of STIGs will be discussed later in this presentation. This project must be accessible by a wide audience. It must include the technical depth which is necessary for a cybersecurity professional to diagnose issues described by our tool, while also being intuitive enough to not require training. The project should be easily deployable and scalable and minimally intrusive. It should not be a burden to have on one's infrastructure, and it should be a background assistant that simply gets spun up and works. But before we continue, we would like to acknowledge some of the amazing people that helped us along this journey. Thank you to Victoria Walters for her insight and advice on project management and planning, as well as advising us on the project direction and goals. To Nagesh Hattie for support and communication with our sponsor and administrative assistance. To our IT operations team for consistent technical support while utilizing enterprise infrastructure. And finally, our sponsor team, who asked to remain anonymous, for providing us with this opportunity and their continual guidance throughout the process of making this tool. As alluded to before, the purpose of this project is to primarily ensure STIG compliance. But what is a STIG? A STIG is a security technical implementation guide developed by the DoD Cyber Exchange operated by the Defense Information Systems Agency. STIGs provide standards on how to configure operating systems, software, and other computer products to meet government standards for security. They are primarily created for use in government systems, but provide a fantastic baseline for independent organizations to reach for that level of security. Let's take a look at the most recent guidelines for Microsoft Windows 11. Here is a small segment of the information provided in a STIG XML file. These are meant to be machine readable and are comprehensible by our system. Let's take a closer look. This is one of many rules defined within this file. This rule states, the act as part of the operating system user right must not be assigned to any groups or accounts. This makes sense to ensure access control of the system. Here's a short explanation on why the STIG is to be implemented, a severity level of the vulnerability if it is not fixed, and a suggestion on how to remediate this problem. The tools we have configured are able to take a file like this one and to automatically check if these violations are occurring on the system. That information is then sent to our data visualization software, Heimdall. But why Heimdall? Heimdall was desired expressly by our sponsor for its ease of connection with popular STIG scanning tools. It also contains native access control through an account system, allowing users to only view scans they have the clearance to see. This protects knowledge and vulnerabilities in important systems from being compromised. The ease of connection is facilitated via MITRE Security Automation Framework command line interface. This tool takes in the output of our STIG scanning tool and converts the data into a format decipherable by Heimdall. And it is easy to access, not requiring any software to be downloaded on a user system. They only need to access a locally hosted web page from their browser. Here's a representation of our data pipeline. It is purposefully incredibly simplistic. Tools will send their data to the MITRE Security Automation Framework command line interface, or MITRE SAF CLI, and that data will be sent to Heimdall. Our STIG scans are being handled by a tool called SCAP Compliance Checker, or SCP, which is run through an Ansible playbook to automatically perform scans on a predetermined basis. One of the other tools not mentioned explicitly, but has been implemented with our system, is Microsoft Secure Score, a vulnerability quantification tool specifically designed for Windows. All this information is converted into the Heimdall data format and presented in our visualizer. Other tools can be included and removed incredibly easily. MITRE SAF CLI supports multiple other tools that could be useful for one specific architecture and can be implemented into the tool as a whole. The modular design is important for ensuring usefulness on a wide variety of architectures. Here's what the actual visualization looks like. Upon login, one will be presented with this screen. In this case, we will look at a single machine, an Ubuntu machine without any security-focused modifications. We can see that it has passed 46 tests and failed 121. This is also visualized by some pie chart graphics for ease of comprehension. As we scroll down, we can see the specifics of each test, what was passed and failed, a name and explanation of each test, and a short recommendation for how to remediate them. These are taken directly from the STIG files provided by DSUB. We can also compare multiple machines on the network. This helps to detect patterns on if certain areas of an organization are lagging behind on security standards. We can also check a timeline to see how the security of an infrastructure changes over time with each additional scan. Currently, we only have a few tools natively implemented into our deliverable. We would like to increase this number and provide the functionality to turn on and off tools from a single location. The tool also still needs to be easily initialized. At the moment, we require a bit too much information from the end user to have it be truly automatic. The tool should be able to be turned on and let run without micromanaging it. And of course, the security of the tool should be ensured.